So for this, we're going to determine the interval of convergence, and again, I'm going to use the ratio test. So here we go. First, I want to figure out this ratio, so I'll do that. Remember, when you take the absolute value, the -1 to the n power is always going to go away, because that only changes between -1 and 1. So if you take the absolute value of that, it's always going to be +1. So we don't have to write it. So I have that, and I'm going to change, well, I guess I'll keep the n plus 1. And I'm going to change this. Well, that'll be 2n plus 2, so that's just the same thing as x to the 2n times x squared. And in the bottom, this is just, this is just 4 to the n times another 4. And that 4 to the n cancels out. And the n times x to the 2n cancels out. So what are we left with? We're left with n plus 1 times x squared, all divided by 4n. And remember, this part is the part that has the n's in it. So hopefully you can see that if we take the limit of that, that's the only thing that we have to be concerned with. And this goes to 1/4. The x squared stays there, so we just have 1/4 x squared. But that is the same thing as x squared over 4 in the absolute value, which is the same as the absolute value of x squared equaling, the absolute value of x squared all divided by 4. There we go. I didn't put in the less than 1 part. So the ratio test says that if I have this limit and it is less than 1, then my series converges. So I have to figure out the x values that make this less than 1. So I multiply both sides by 4, and I get the the absolute value of x squared less than 1. Less than 4. And, well, that becomes a little bit trickier to think about. But I know that maybe, what if I had the absolute value? This is the same thing as saying x squared less than 4, right? Because the square takes care of the absolute value anyway. But I can plug in, like, the furthest negative that I can go is -2. If I did -3, I would get 9, and that doesn't work out. And the highest I can go is +2. No, +4? No, yeah, +2, because then 2 squared is 4. So if I'm just thinking about this, and the lowest I can go is -2, and the highest I can go is +2. That's just by inspection. So you don't even have to, if you can square root both sides, but that's hopefully something that you can see. And I can plug in anything in between. If I plug in 1, that's fine. If I plug in -1, that's fine. If I plug in 0, that's fine. Alright, now I have to check my endpoints. How do I check my endpoints? Well, I'm going to check -2. I'll do that first. Check x equals -2. And where am I checking it? I'm checking it in my original series. And I want to see if this converges. Remember, the ratio test, when this equals 1, if it were to equal 1, the ratio test would be inconclusive. So we have to, figure out the values of x that make it equal to 1 and test them individually, because the ratio test doesn't tell us. Well, the values that would make this equal to 1 are these exact numbers. -2. If you plugged in -2 there, -2 squared would be +4. 4 over 4 is 1, so it makes it equal to 1. So we'll try these and see what happens. I'll plug in a -2, and I'll start reducing stuff. I'm only going to look at the sequence in here, and then I'll just use my prior tests that we already have dealt with. Just something I want to point out, if I have -2 to the 2n, that's the same thing as -2 squared raised to the nth power, so that's actually the same thing as 4, right? 4 positive to the n. So this actually changes to 4 to the n divided by 4 to the n. Look at that. So then I have the series n equals 0 to infinity of just -1 to the n. And that oscillates back and forth from 0 to, or sorry, -1 and then +1, and then -1 and then +1, or sorry, 1 then -1 and then 1 and then -1. So if we add it up, the partial sums would be, well, the first one would be 1, and the second one would be 0, and then the third partial sum would be 1, and it just oscillates back and forth. So this actually diverges. So we do not include -2 because the series would diverge. And it turns out, if we plugged in a +2 to this, well, we would have this, and we would square it, so this negative didn't even matter. We would still get 4n, and we would still get a divergent series. So this is, in fact, the interval of convergence. We do not include any of the endpoints, and there you are. That's it.